solve the next question of thermodynamics, that is a certain amount of an ideal gas. There is a certain amount of an ideal gas is initially at pressure T1 and temperature T1. Since it undergoes a constant pressure process from 1 to 2, process 1 to 2, such that T2 is equal to 3 T1. Then it undergoes a constant volume process 2 to 3, such that T3 equal to T1 by 2. The ratio of the final volume to the initial volume. What is the final volume? Like mu3 V3 by initial volume, suppose that V1. So first draw PV diagram. So PV. So in this it is written that it undergoes a constant pressure process. So constant pressure process, it may be here 1 to 2 or it may be this 1 to 2. First we have to identify which is correct. Is it from 1 to 2 like this, from left to right, or from right to left? So for that we have to solve ideal gas equation, which is as you all know, PV is equal to nRT. N is the number of mole. So and pressure, volume, number of mole, universal gas constant, and R is the P is the temperature. So constant pressure process, for constant pressure P is constant. So V is directly proportional to T, because these values are also constant. So we can write not here. We can write P and P not P, but V1 by V2 equal to T1 by T2. Then you can write V1 by V2 equal to T1 by T2. We know that T2 equal to 3 by 4 T1. So substitute it, V1 by V2 equal to T1 and by 3 T1 by 4. So T1 cancel out, 4 by 3 equal to V1 by V2. So from here we can say V1 is greater than V2. So the process is this one. Then we can raise this one, but this is not our process. So like this. Then it say that it undergoes a constant volume process 2 to 3. So from 2 to 3, this is constant volume process. So we can here we can write that V2 equal to V3. In the question it is asked the ratio of the final volume to initial volume. So here is written, here we can say that V3 from constant volume process V2 equal to V3. But we have to identify V3 by V1, which is similar to V2 by V1. And here we already calculate V2 by V1, which is 3 by 4, and its value is 0.75. So our correct answer is 0.75.